Hello students, now in class 11th I will tell you about uh, the degrees of freedom, law of equipartition of energy and atomicity of gases. Three topics I will take today. So first I am taking the degrees of freedom. Degree of freedom. It is defined as the total number of independent coordinates required to specify completely the specify completely its position and configuration of a thermodynamical system. Defined as the total number of independent coordinates required to specify completely its position and configuration of a thermodynamical system. This is the thermodynamic definition. But actually, we say that the directions in which the molecule is free to move, that is called the degrees of freedom. It is the number of directions in which molecule is free to move. So the monatomic molecule have three degrees of freedom, which are the translational energies, which are translational energy in X, Y and Z directions. So for monatomic, gas degrees of freedom F equal to 3. diatomic gas or diatomic molecule. Diatomic molecule F equal to 3 translational degrees plus 2 rotational degrees. So total is 5 degrees of freedom. F equal to 5. This is degree of freedom. So thus diatomic molecule have the 5 degrees of freedom, 3 translational degrees and 2 the rotational. Rotational it may have the clockwise or anti-clockwise. So 2 degrees are from here. So this is total the 5. And in case of polyatomic molecule F equal to 3 translational plus 2 rotational degrees plus 1 vibrational degree. So thus there are 6 degrees of freedom. So a general formula for finding the degrees of freedom. Formula for finding degrees of freedom. F equal to 3n minus b, where n equal to number of atoms in a molecule and b number of bonds. So now you can apply to this one. For monatomic F equal to 3 into n is equal to 1 minus 0. So this is equal to 3. Here the n equal to 3 and b is equal to 0. Single molecule, so that is a single atom, so that have no bond at all. For diatomic, F equal to 3 into 2 minus 1. 6 minus 1, so this is equal to 5. Here the number of atoms is equal to 2 and number of bonds equal to 1. For example, your hydrogen, oxygen, nitrogen, etc. So this hydrogen that can have only one bond, nitrogen molecule also have the one bond, oxygen molecule also have the one bond. There is only one kind of bond. So if the bond does not mean that what the nature of that bond, we are not concerned with that. We are concerned only that how many bonds are there, 1, 2, 3, 4, etc. For polyatomic, F equal to 3 into 3 minus 2. So this is your 9 minus this is now 6. So for example CO2. So this will be like this. This is carbon, this is oxygen, this is oxygen. So we are having this is number of bonds. So 3 number of bonds. This is the triangular structure. If suppose the structure is linear, F equal to 3 into 3 minus 2. So for linear structure, what we have that this is the molecule, this is the molecule. Like this, so then we are having to this one. 3 molecules are there, but there are only 2 bonds. This is the bond, this is the bond, this is the bond, this is the bond, this is the bond. So now this is equal to 9 minus 2. So it has now 7 degrees of freedom. So thus knowing the value of knowing the molecule and number of bonds, you can calculate the degrees of freedom of the molecule. So this is the degree of freedom of the molecules. So you like, share and subscribe this video. Thank you.